Now, for this problem, we have an inequality. And I remember if we multiply or divide by a negative, we have to flip the inequality sign. So it's important here that we understand that x could be positive or negative. I don't know which one. X could be positive or negative. And I have fractions, so I don't even like that. But first thing that I'm going to do is get a common denominator, or clear the fraction, multiply by a common denominator. So the common denominator here is 4x. But this is like when I figure out the answer, x could be a negative number or x could be a positive number. I don't know which one. So I have to make two cases here. This is the tricky one. Anytime you're multiplying by x with an inequality, you have to make two cases. And those two cases are when x is less than 0, meaning negative, and then when x is greater than 0. Greater than or equal to, but let's just say greater than 0. Yeah, we can say greater than or equal to 0. Because this is saying negative, so when I multiply or divide by negative, I have to flip the inequality sign. Since x is not negative here in this case, then we don't have to flip the inequality sign. So I'm going to do both of these. Yeah. So this is going to be hard to understand for some people, but we're saying that x is a negative here. Whatever answer it's going to be negative, and that means I'm going to flip my inequality sign when I multiply by the common denominator of 4x. So let me do that right now. So I got to distribute it in. When I do 4x times this, the 4's will cancel out, leaving me with just 3x. So I got 3x right there. When I do this part, the x's will cancel out, leaving me with just minus 5 times 4. That's negative 20. So that's what I'm going to do there, negative 20. And then I multiply by a negative, because that's the negative there. So I have to switch this, less than. And then when I multiply this part, the x's cancel out, so I just get 4 times 7, that's 28. And then I could just solve it like normal. Plus 20 plus 20. 3x equals 48. Divide by positive 3. Whoops, not equals. Less than. And then divide by 3. X less than, was that 12? 16. 16. X is less than 16. Well, we said x was negative anyway, so definitely any negative number will work. Hopefully that makes sense. So just anything less than 0 would work, right? Because we already assumed this to be true for this case. Hopefully that makes sense to you. X is less than 16. We already said it was negative. Okay, so now let's assume that x is positive. How would this look if x was positive? Well, we do all the same things. I'm going to multiply by 4x, except for this time I'm going to keep that sign the same. So everything happens the same exact way, except for I just get x is greater than 16. Right? It's all the same calculation, so x is just greater than 16. And now I want to combine my solutions. So I can say x is less than 0, so x less than 0, or x is greater than 16. So this part is the key part, because that's when you make a different part, different signs. You switch that sign, you know there? Okay, we can move on. Let's take a look at this, solving this. So we have an inequality, but also absolute value. I'm going to show you a little trick here with absolute value and inequalities. So let's see what we got here. The first thing I do, hopefully you remember this, is to get the absolute value by itself. So I'm going to add 5 first, and that goes away, and I get 3 times the absolute value of x plus 5. That's not a 5. Come on now. And then we got less than 12. And then I will divide by 3. Divide by 3. I switched the colors. Now, here's the trick with absolute value. It's saying x plus 5, whether it's negative or positive, has to be smaller than 4. Now, what I can do to make my two cases. Like that's normally what we've done, make two cases. But I think the easiest thing is just to take this, copy this sign, and then make a negative over there. Take this 4, make a negative. Because the inside here could be negative. And so what I'm going to do now is I'm just going to have negative 4 less than x plus 5 less than 4. And then I'm going to solve this all at the same time. So it's kind of like I have two equations and I'm solving them at all the same time. So if I subtract 5 from the middle, I have to do it from both sides of the outside, both outsides. And so I just get less than, and I just get that. And there's my answer. X is between negative 9 and negative 1. It's beautiful. It's beautiful. So there we go. There we go. There we go. There we go. So that's the trick there. It's pretty nice. Everything's pretty good. Let's take a look at one more thing. One more thing. We're gonna get this one more thing. So if we're solving a radical equation, that's what this is, a radical equation. We've looked at this before. Minus 15. We're trying to get this by itself. So minus 15 there, and then it goes away. We got that 4 times the square root of x equals 15, 40, 12, 11, 10, 9, 8. Negative 8, and then we stop. We stop here. Well, actually, we could do one more step, but we don't need to. We could stop. And then I'll get the square root. The square root of x equals, whoops, that's a positive, isn't it? And so positive 4. And that'll be negative 2. And then we'll say no solution. You go, what? What are you talking about? Because the square root can't give you negatives. No matter what. If I put a negative 4 in there, I don't get a negative 2. I get 2i. I get a negative square root. That's an imaginary number. So we can say no real solution, actually. Real solution. This is the one, you got to remember that one. You got to remember that case. You can't have negatives. You can't do it. It won't work. It's imaginary numbers. If you have the negative, you can't do it. There's no solution, no real solutions. Well, I'm gonna stop this one right there, and then we go get the. Whoop, there goes my notes. We're gonna do quadratics on the next ones.